Hello, everyone. My name is Farzad Yousefzadeh, and I work here as a software engineer. You can find me online by Farzad YZ practically everywhere. I used to be an aerospace engineer with a bit of background in astrophysics and scientific programming, but then I figured out I need to make my own blog. So I got into web programming, and I haven't gone out yet. I live here. I work in Helsinki branch, and I'm usually more active on Twitter than my own job. I've been a front-end developer for almost 6.5 years now. Been doing a lot of other stuff too, but mostly focused on user interfaces and front-end side. And regardless of all the frameworks and tools that I've been using during this time, the UI development has always been challenging for me. I started when AngularJS was a thing, when jQuery still had an empire. But right now I work in React, and still everything is hard. Is there anyone that can relate to this here? Cool, I'm not alone. All right, so let's go into a bit of history first, then I'll get to my point for the talk. All the user interfaces and GUIs started from command lines. And command line was an interface that was really easy to work with. It wasn't interactive, it was text-based. And basically, if you wanted to work with a command line, you had to know its grammar and syntax. So it was up to you to talk right to the machine. If you were rambling something that the machine couldn't understand the syntax, it would just throw an error, hey, you need to learn how to talk to me. And everything was sequential in command lines. Nothing was happening at the same time. It was always doing something, and when you were asking the machine to do something for you, you had to stop doing everything else until it was finished. But it's not the same thing that we see in the user interfaces right now. There is a great book that talks about developing user interfaces using state machines and state charts by Ian Harax. I hope that I'm spelling his name right. He uses this word, direct manipulation UI. Basically, graphical user interfaces that require you to manipulate some way. In direct manipulation API, like let's assume Twitter feed. When you open twitter.com, there is a main feed, and while the main feed has loaded and you're scrolling your timeline to see everything, the sidebar is still trying to fetch recent hashtags for you throughout the world. So everything can happen at the same time in user interfaces these days. And not everything is sequential. Many things can happen in the background, many things can happen asynchronously and concurrently. And you can practically ask a machine to do whatever you want. And you are now on your own understanding how the machine should work. So you can practically log out while you're still logged out, and that happens. But why do I think user interfaces are hard? Well, there are a couple of reasons. I'm just going to go over this quickly, because this was a draft of the slides that I gave at Holy.js St. Petersburg 2 weeks ago. And there might be a bit of overlapping content if you have talked to me for the past 6 months, or you've been in a couple of local meetups that I've been talking. The user interfaces are hard because of different reasons. One of them is that they need to run on different platforms. Basically, you nowadays can write a React application that can run technically as a React Native application as well. And you can run it on, I don't know, like command line using different renderers. And platforms are different. When you want to run something, the same thing on different platforms, because of the difference in the platforms and the standard implementation in them, you get into errors. And all these standards are not always correctly implemented. That's exactly why we have browser lists. And that's exactly, you can see a dimmed background of browser compatibility here in this slide. That's exactly why we remember IE. Besides those, styling is always hard. Responsiveness, different viewports, different screen readers, I don't know, different mobile devices, different sort of rendering rules. All of them makes user interfaces as a whole really hard and challenging to develop. There are also different sources of data. I can change the URL. I can initiate a WebSocket connection. Probably I can do a lot of search button clicks at the same time. There can be I don't know, different stuff can happen, and the user interface can get this required data from different sources. It's not just the user itself. It can be anything else. And the consumers of the UI that you make these days are really like the zombies, unpredictable. You don't know whether your UI is used by a human. Your UI can be embedded as an iframe in another UI. And those are all challenging and added complexities. There's also accessibility. There are drunk people everywhere. There are people who are blind. There are people who need to use your UI not in an ordinary way. And this also is another added complexity. There's also I-18N, different languages. And I remember that I was talking to Futurice here in a bar, and he was drunk enough to talk about different sort of CSS declarations and how Flex is amazing because it doesn't have right or left. It has a start and end. And that's because it wants to respect vertical and horizontal typography. And sometimes, like the direction also, like I'm coming from Iran. It's a company that has an alphabet that is right to left. So web development wasn't easy there because everything needs to be right to left. The typography, the sizes, even the numbers are different. I think it's a hype thing right now. Remember, considering that there are 1,000 solutions just for JavaScript state management right now. And with all the modern frameworks nowadays, they all come with a promise. They say that if you write the render in our own syntax, whether it's JSX or template or whatever, and you give us the state, we will take care of the render and the updates. And this is important because the state part that is highlighted here, I think at least it means the behavior of the UI we create. So if you want to control the behavior, if you want to tame the UI so that it works in a way that you want and is supposed to, you need to tame the behavior. And the behavior, I think, lies in the state. I might change my mind to the end of this talk. So the title of the talk was about explicitness and consistency in UI. And I think if you want an explicit UI, you need to be able to make it predictable. And with the promise, with the low opacity in the center, you can see that if you want explicit state, you will get explicit UI. Sometimes when we're doing state management, we might make some mistakes. And some of these mistakes, one of them, is implicit states. What does implicit mean? It means something that is not upfront verbose enough for me to see. Like what? Okay, there's a simple fetching here. If you want to fetch something from server, there might be something happening before the fetching. You click the fetching, takes some time, and then some other things might happen after the fetching. I've usually seen people modeling it with one Boolean. Not good, right? Because whenever you're using Boolean here, you probably just want to control the true part. What about the false part? What happens when is fetching is false? Is it not fetched yet? Is it fetched but there is data? Fetched, there is error? Fetched, there is corrupted data that doesn't match with your schema? Or there is a data that is valid? Who handles those when you're just modeling it with one Boolean? Well, yeah, I didn't want to use memes, but seriously, Booleans are everywhere. But there are some problems with Booleans. Booleans don't inherit any meaning. They don't carry any meaning with themselves. That's why, as developers, our job is to attach meaning to Booleans. So Booleans will get some meaning in the context of the domain that you're working in. Also, we need to use Booleans if we care about both of the sides. You don't get to use Boolean if you only care about the false or the true part. What happens to the other side? Also, use multiple Booleans. Multiple Booleans is horrible if you don't know what you're doing. And use it when you only care about all the combinations. Because 2 Booleans will be 4 different variations. If you don't take care of it, you're either going to run into runtime error or unexpected behavior in UI. And that's exactly what you tell your user, I don't know how it happened, but restart. That's exactly what happens. So what would be a better way to model that fetching? Well, I don't know. Union types. You can do before fetching. You can do fetching, fetch valid data, and corrupted data, and fetch error. This actually is not invented by me. It's coming from a great article called Slaying an Anti-Pattern in UI, if I'm remembering correctly. Sometimes we run into missing states. Sometimes we're dealing with the states that are missing and we don't know they're there until there is a problem. Error parts. How many of you have worked on a UI that you've been given from the design team some like design, and everything is happening in the happy path? What happens? Like, do designers give you designs that handle the errors? Do they give you designs that handle the empty states? I don't know. I haven't had the chance to work with perfect designers who handle those. And I don't blame them. It's not their fault. We'll get to that. Well, yeah. You need to find a better way so that when you're modeling in that way, you have first-class support for all these edge cases and missing states. Sometimes we have conflicting states. What do I mean by conflicting states? Well, this is based on true story. This is a layout props in the code base that I'm working right now. Used to be, actually, we fixed it. So that we wanted a component that renders the main the layout in our application. And we had 3 different layouts to support. We had main layout, header, and right. So I saw this piece of amazing code in our code base. And I think there are a couple of problems with that because, well, we wanted to use it in this way. And we wanted to have main layout, header layout, and right layout based on the interface. And we were happy that we were going to end up with 3 different variations. But the truth is, it's 8 different variations. A better way would be to have a union that doesn't allow you to make mistake. And even explicitly go on and create the components for that. Because if you give the developers a way to make mistake, someone at some point will do. Don't do it. If you don't believe me, this is the Slack. This is the Slack. I got a screenshot with the approval from my colleague who made the mistake. And here I call it dangerous for humanity. When you're thinking about Boolean and their problems, it's not always about primitive Booleans. Sometimes it's about optional and maybe types. Because if you think about it, optional types are kind of like Booleans that are indicating whether the value of a certain optional type is present or not. So don't put stuff either as optional or Boolean in an interface or a group data that are mutually exclusive. What I mean by mutually exclusive means that only group relevant data, only group data that needs to be updated all together. Otherwise, they're not relevant to each other. And these things shouldn't be grouped together because they're not supposed to happen at the same time. When you get to model this sort of stuff in UI or other parts of the software with Booleans and with optional types, you're limiting yourself and your business because if there is another spec coming in your business requirement later on that wants you to add a feature or fix some bugs, you might need to extend that Boolean or optional type with something else. And that's the point that you definitely need to refactor it. And it also adds to the complexity because with n Booleans, you're going to end up with 2 by the power of n different variations. Also, when you when you combine things that are not supposed to be grouped together, then the priority will matter because based on the order of the execution, something will override another one. Because in this case, for example, the layout will end up being header, not main. So just to show you how this stuff might easily happen and how the complexity might grow, I'm going to show you an example that I haven't written myself, but it sometimes can be really eye-opening to see how we underestimate the complexity. So I'm using different, I'm just rendering different buttons here. And I want to support 4 different sizes, small, medium, large, and extra large. And 3 different variants, primary, secondary, and default. Also 2 different types. The button can be either disabled or active. They're not very much, right? They're just basically one underlying component in any design system with basic features, as you can see here. But they will have 24 different variations. So the UI is complex. You just don't see the complexity up front. Some other times, we might end up using derived states. What do I mean by derived states? I mean that Well, we know that our UI is operating in certain finite amount of states, but we're not trying to define them ourselves explicitly, but we're deriving them from data. Consider a list of articles. In an article list component, you're trying to reason about something and render something based on the length of the list of articles. This means that in this one line of code, you're handling two different states. You're handling the happiest state that renders a list of the articles, and you're implicitly handling the emptiest states. This is the state that is derived from the data. And this is a mistake because this is not verbose enough for other developers to understand it. Also, in the article component itself, you're also relying and reasoning based on the length of some pictures list in the article schema. And this means that you're only handling the happiest state. What happens when the picture is not present there or is empty? Does this code sound familiar? Have you ever used Redux? Of course. Or, well, the new shiny React hooks with their user reducer hook. Consider that your API has a private health check endpoint that you can just ping it to see whether the API is up and running or not. In order to model that, you might have a checking to show that the request for getting this status is pending or not. And the API will either give you an error or a status. And in order to do pattern matching with the switch case there, you switch on top of the event type. And when it's set checking, you do stuff, check success and failure. But the thing is, when you're set checking, you're checking the true, but the error is undefined. It means that like this error should not even be here, because when you're trying to do set checking and when you're trying to asking for the status from the server, the client doesn't even need to know about the error. It means a grouping of irrelevant data. So yeah, if you wanted to make it right, you could have idle, checking, success with some status, and failure with some error. This is exactly the remote data pattern in that article I mentioned. And if you think this is really obvious and people don't make mistake, this is a screenshot from the master branch of a very famous library called Formic to manage forms in React. Very much adopted, highly adopted, very famous. And you can see here that it's modeling different sort of pending operations with Booleans. So it has is validating and is submitting here. But the thing is, they are mutually exclusive. So you can't be submitting the form while it is still validating. And also, you can see that it's grouping all the data in a single object. It means that it's irrelevantly grouping data together, because these data are not going to be updated all together. So they're not relevant. I've been talking about everything, all these problems and all these mistakes. Let's get back to UI a bit and talk about it. User interface is event-driven. It has always been event-driven because event-driven system was one of the best solutions that they could find to simulate graphical user interfaces when Smalltalk was a thing, like 40 or 50 years ago. And from that time, since it was suitable enough and it was scaling for people's use cases, everyone just followed that pattern. I believe that was firstly developed by the team that Alan Kay was moderating. And also, even the first draft of object-oriented programming introduced by Alan Kay didn't even talk about implicitly updating some states in objects and hidden relations. It was always talking about objects that are message passing to each other. From that, since we have user interfaces that are event-driven, it might be suitable for other solutions like Redux to follow a pattern that can respect the UI to be event-driven. And there are some problematic conventions there. Because of this event-driven nature of UI, solutions like Redux, they need to follow a paradigm called event action. It means that you send an event, a signal to UI, and your UI is listening to that. And when the UI receives that event, it tries to run a set of side effects. And even without the context of React and Redux and all these shiny frameworks, in UI, you can just register an event listener on the click of a button and try to run some side effects there. And in order to manage it, for example, if that button was an authorization button, then you need to dispatch something and dispatch that I'm authorizing the session here, so do something in React to that, and then run the authorized handler, which then this authorized handler needs to be aware of the current state and do something, because always in React to one event, you won't run one side effect or the same side effect. And it is problematic because all these things, you see, since UI is event-driven, it means that the only model of subscription is registering event handlers. And that means that event handlers are soon going to grow enough that you spread the whole business logic of your project everywhere. And there was also this report by Adi Osmani on Smashing Magazine a couple of days ago, not a couple of days, but a couple of years ago, that he was talking that one of the most memory problems they see from the tracking service in V8 embedded in Chrome is that people just leave memory leaks there. People just register event handlers and they forget to dispose that. And that was one of the most problems people had with their JavaScript bundles when they were tracking all these applications. And it makes sense because since UI is event-driven, you need to register a lot of event handlers, and it soon gets out of control. No one knows how to do it, and it's really easy to shoot yourself in the feet because you might end up registering duplicated event listeners everywhere, and they might even run at the same time. You don't know about that. It depends on the platform and how they implemented it. Also, if UI is event-driven, it means that if you try to run everything like as event handlers, and you try to subscribe to different events and run side effects in React to that, you're increasing the cyclomatic complexity. And cyclomatic complexity is a term that means the line of code and the amount of the code to be nested is increasing by the growth of the business. Also, it means that it's really hard in an event-driven UI to detect similar states. And what we're suffering from here is bad modeling to separate similar states, because most of the times your UI is kind of like the same thing, but a bit different. And those are similar states. For example, in that example that I showed you for authorization, the problem is that you need to have a couple of event handlers, and this also happens in solutions like Redux. And you need to have a couple of renderers, and you need to model them separately. Instead of thinking about the UI as one entity as a whole, you get to model them separately, and it's problematic because technically you're allowing your user to log out while they're logged out. This shouldn't even happen. It's not even true. But then you need to push all this awareness of different states to your event handlers, or you need to handle it on the rendering level, which is the last thing you want. And also you need to test something that was not even supposed to happen, but you technically opened it, so you need to test it and guard against it. Whereas in a good modeling, you only want to log out when you're not in the login. I haven't found any research, scientific research, proving these statements that I'm going to say, but I'm just going to go on and say it. I think as humans, our mind kind of works like a parser that is trying to parse a scripting language, and it tries to parse it from top to bottom, and it fails whenever it finds something that is asynchronous or concurrent, or basically the dimension of time. And as humans, we're really bad at considering and loading enough amount of data that is sequentially happening and then reasoning about that. And that's exactly why, as humans, we are error-prone, and we need a better way to modeling. So we need a better computation modeling. And that's where I think final state machines and STATECHART might help. I'm not saying they're silver bullet, but from the past 6 months that I've seen them, I can't just unsee them. I've done many projects with them lately, and most of them side projects because it's really hard to talk your team or business into this. And I've managed to survive Node.js as child process subscription model with them. So they're good. In a final, is there anyone here who doesn't know about final state machine or STATECHARTS in particular? Okay, so really quick introduction. Final state machines are a mathematical model for computing, and they try to solve problems that can be modeled in a finite amount of memory. And it's really good for graphical user interfaces, because in graphical user interfaces, if you want to manage states, then you're usually having a concrete checkpoints, a set of concrete and finite checkpoints that you call states, and you want to transition between them based on different events and conditions. And that's why final state machines are really suitable for this case. And a final state machine is a machine that you define the behavior of your machine in it by mapping the states and the events that those states can accept, and then a set of side effects that can run and react to that. And because of this, your transition function will get the state and the event, and will try to compute what's the next state, and what are the side effects that you need to run in the interpreter level. It's kind of the same thing like the reducing logic in Redux or use reducer, but different. And the difference is, the reducing logic is advocating purity. You've heard it in everywhere from the first day of when the Redux came out that your reducers they're supposed to be pure. But the thing is, in UI, we are highly dependent on side effects, and especially running them conditionally based on the state and the event. And that means the UI has to be computed in a way that it advocates idempotence, not purity. Also, in the event action paradigm that most people use nowadays to manage the complexity in user interfaces, people need to take care of guarding, because if you don't consider the state in event action, it means that you need to do if-else everywhere in order to run different behavior based on the current event. But here in final state machines, since you're considering events at the time of construction, you're not even allowing invalid stuff. So it works kind of like a firewall that just ignores everything that is invalid and just accepts something that you told it to accept. OK, yeah. Also, one of the good things is that the Redux developer tools and the talk that Dan Abramov did at JSConf was saying that Redux can record everything, and since all the updates are idiomatic and is coming from a pure reducer, you can travel to past. But guess what? With final state machines, since everything is upfront explicit, you can even go farther in the future and see what's going to happen, because everything is going to be idempotently computed. All right, there are some differences, yeah. So I said that we need to treat UI and model everything as a whole entity and not separate, because details and differences in separations are going to be problematic. But then how can we do it and at the same time keep the logic idempotent and like modular? Well, I guess the answer might in future be final state machines and actor model, I guess. Actor model has been an architecture used in real-time languages such as Erlang, and has been around for, I think, more than 2 or 3 decades, and has been working well for at least WhatsApp. And I think that might be the solution, but who knows? So as some takeaways, as Richard Feldman said, make impossible states impossible by not allowing anything to happen technically if you don't want it. Also, make irrelevant data unavailable. Just group whatever that makes sense and whatever that needs to be grouped in the first place. And do not test something that is not supposed to happen. Don't open doors technically. Also, as Richard Feldman in the same talk said, testing is good, impossible is just better, right? And I tweeted a while back that I said, if you don't model the behavior of your software, the behavior will implicitly shape around the code you write. So either you need to be in control or the software. And also, simple user interfaces are really easy to construct. Everyone can make UI nowadays. These are the complex ones that need proper design, and you need to think through them. And a very, very accidentally image that was taken at Helsinki airport. Don't let your software bully you. Thank you very much.
Thank you, Farzad. We are over time already, but I think we can have questions anyway.
Can you show us one of your state charts? I'm just curious to see what they look like.
OK, so I made a service called HSL Zone that gets your geolocation with using HTML API and detects your zone, and it can also monitor the changes in that and lets you know by local notification. Works as a progressive web app and React Native, not marketing it here. But I'm going to talk about it next week in a meetup that happens here. But sure, I think I have it somewhere here. Here you go. I'm not sure how useful it's going to be, but it's definitely going to be useful when I talk about it next week. It's actually not pure state machines because state machines will hit some problem in order to model real-time user interfaces soon because of a state explosion, because not everything can be concrete and finite. That's why there is a paper written by David Harrell on top of it called the STATECHARTS that brings a couple of things like a structure and extended states called context and custom conditions and this stuff, so that makes it be able to model the UI. But yeah, this is basically how the machine works. And I gave a talk at React Finland about this. Is because the implementation of machine, since it's framework agnostic, it doesn't know anything about the context that it's going to be run in. So you get to somehow reuse the code and share and port the behavior to many different even languages and platforms just by modeling it in finite state machines. So the way that the finite machine works so quickly is that it has an initial state, and you define a map of states to the events that it needs to accept, like the ready state here. You're saying that it only accepts the text zone, and when you go to when it receives the text zone, it transitions to zone pending, and when you go to zone pending, you do other stuff. But more on that later. If you're keen enough to know more about it, I've had a really hard time getting up and running about this because there are not enough resources I'm not coming from a CS background, so there are not enough non-academic resources to get you up and running about this. So it might be helpful if you're interested. All right, I guess there is no question. Thank you.